Okay, I've now added 25.00 kilojoules of energy to my 100 grams of ice that was supercooled to minus 10 degrees. We noted in the first problem that it took 2.06 kilojoules to bring it to the freezing point. So this amount of distance from here to here is 2.06 kilojoules. And the next question I have to ask myself is, when I add 25, do I have enough to go from 0 and past this point? That is, do I have enough energy to melt it all? So how much energy do I have to melt the ice and keep heating it? Well, if I've started with 25 and I've used 2.06, I have 25.00 minus 2.06. So I have 22.94 kilojoules of energy left after I raised it to the freezing point to melt it, to raise it to the boiling point, to boil it. I need to know how much I have. So the next question I have to ask myself, and I'm just going to write this up here, is I have 22.94 kilojoules excess from the 25, and is that enough to melt the ice? Okay? So I go over to the second equation here. I'm now in this part here, and when I add 25, starting at 0, do I have enough to go beyond here, or do I stop in this two-phase region? Okay? So I use the second equation. Q is equal to N delta HF. I'm going to write this as Q2, and that's the amount of energy required to melt the ice. And I have 100 grams, 0.0 grams of ice. And I know that the molar mass of water is 18.015 grams per mole. And this gives me the number of moles of water that I have. And I know that the latent heat of fusion is 6.02 kilojoules per mole. So I get out my calculator and do this calculation, and I get 33.42 kilojoules. So what that's telling me is that it takes 33.42 kilojoules to melt the ice. I started with 25. 2.06 was used to bring it to the melting point. I only had 22.94 kilojoules left. So I'm somewhere in this two-phase region here. And so the final temperature is 0 degrees Celsius, and I have a mixture of ice and water.